going to finish 3.4 today, and if I had an x to the fifth polynomial, how many roots does it have? It ends up having 5. So if I had x to the fifth, something, 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 plus 12, what could the roots be? The roots could be any factor of 12. 1 or 2 or 3 or 4 or 6 or 12. Why not 5? Because 5 does not go into 12. If there is an x to the fifth polynomial, then there are actually 5 factors, right? So a factor could be x plus 3. If the factor is x plus 3, what's the root? X equals negative 3. And then if a factor was x minus 1, what's the root? 1. What about x minus 2? 2. Now, could it be x plus 5? No, why not? Okay, and this is really important. This times this times this times this times whatever's there equals x to the fifth. Right? When you do the multiplications, all of the original x's will combine to be x to the fifth. Where does the 12 come from? The 12 is actually this times this times this times this times whatever goes there. Those numbers multiply to be 12. So why is the 3 a possibility but the 5 is not? Because 5 does not go into 12. So I have 3 times 1 times 2. It can't be a 5. But it could be a 2. So if I have 3 and 2 and 2, what does the last one have to be? 1. And I'm not sure if it's plus 1 or minus 1 yet. But that is the direction we're going. The first term in a polynomial, this is the product of all of the left side of the factors. The x times the x times the x. And if it happens to be like a 4x, 4x times 2x times 3x or whatever, those terms multiply together to create the x to the fifth. And then the constant is created by multiplying all of the constants together. What about the x to the fourth and the x to the third and the x squareds? Where do those come from? So I didn't write them. I made this up. But all of the terms that go in there, where do they come from? There's some combination of this and that. Right? And they all kind of get mixed in there and it's really messy. But the first one is really easy to figure out. It's just all of the first terms multiplied together. The last term is really easy to figure out. It's all of the constants multiplied together. Right? So if I had 2x minus 1 times 3x plus 7 times x minus 4, can you tell me the first and last term of this polynomial? Well, it would be this times this times this, which is 6x to the third. And what about the last term? This times this times this is plus 28. Okay? And then all of this stuff gets mixed in when we start blending everything together. And that's a lot harder to find out. But the first one is really easy, and the last one is really easy. Does everybody understand that? Okay. Well, let's say I had a polynomial. 3x squared minus 6, let's do x to the third minus 6x squared plus 2x minus 1. Is there a way to know if x plus 4 is one of the three factors? How could I tell if this belongs there or not? Okay, well, let's think about this. If I had a really big number, okay, and that number is made up of a whole bunch of factors, right, like a 3 and two 2s and a 5 and a 7 or something like that, how do I tell if 3 belongs in that list? I just divide it. So 1, 2, 8, 6, 7, and I divide by 3. Does 3 belong in the list? Yes, it does. Okay, what about 2? Let's divide this by 2. Does 2 belong in the list? No, why not? It didn't go in evenly. There was a leftover, right? So, how do I tell if this belongs or not? If we divide it and it goes in evenly, and how do you know if it goes in evenly? The remainder is 0. Now, there are two ways to divide, and I'm going to show you both of them. I could put x and plus 4 on the side of the box. And then I bring down the 3x to the third. And that would be 3x squared. 3 times 4 is 12x squared. Now, this one and this one need to add up to be negative 6. So I need to subtract 18x squared. Is that right? Now I pull out an x, and I get minus 18x. And, ooh, that's a big number. What is that, 72? 4, 5, yeah, 72. So that's negative 72x. Okay? Now this one and this one need to add up to be 2. So I need to add 74. Wow. X. Now I pull out an x, and I get plus 74. 74 times 4 is 296. And 296 and this box need to add up to be negative 1. So negative 295. Did that go in evenly? No, because I got a remainder. So this does not belong. Now, sometimes we can use an easier division. We can use synthetic division. When are you allowed to use synthetic division? When this is x to the first and this is a whole number. That's the only time you're allowed to use synthetic division. Well, hold on. Let me see if they... Okay, we're good. So, I want to divide by x plus 4. What number do I put in the corner for synthetic division? I always put the root in. Okay, not the factor, but the root. So x plus 4, if I set equal to 0, I end up with x equals negative 4, and that goes in the corner. What should I do now? 3, negative 6, 2, negative 1. Drop the 3, negative 12, negative 18, 72, 74, 296. Oh wait. Did I do that wrong? So, negative 12, negative 18, 72, 74. Oh, I messed up on the other one. Negative 297. Did that go in evenly? No, so x plus 4 is not a factor. It doesn't belong in that equation. Let's try another one. X to the third minus x squared minus 24x minus 36. Is x plus 2 a factor? Well, what should I put in the corner? Negative 2. And then 1, -1, -24, and -36. Drop the 1. -2 creates a -3, plus 6, -18, 36, and 0. Is x plus 2 a factor? Yes, it does go into it. So, on 39 through 43, it says, determine whether the binomial is a factor of f of x. So you're going to do the division, and you're going to say yes if the remainder is 0, and no if the remainder is anything else. On 45 through 50, it says, show that the factor is a factor. Show that the binomial is a factor. So on 45 through 50, we know the answer is going to be yes every time. We just want to show that it gives you a remainder of 0. Yep. So then we have this. If I had x plus 1 and x minus 4 and x plus 5, what does that graph look like? Well, it has 3 roots. What does an x to the third equation look like? An x to the third equation looks like this. What does an x to the fourth equation look like? A w. What does an x to the fifth look like? It just has one more turn. So this would be x to the fifth, and this would be x to the fourth, or x to the sixth, and so on. Right? Now, what's the difference between x to the third and negative x to the third? An x to the third looks like this. It starts negative and ends positive. And the other one starts positive and ends negative. What would a negative x to the eighth look like? It's an upside down WW, a double W, something like this. Right? So, this one here is going to hit the x-axis where? -1, right there, +4, and -5. Am I going to start from the top or the bottom? Well, x times x times x is positive x to the third. So I need to start from the bottom and make it look like that. Okay. What about this? Oh, that's all I want. I just want those. Where does that graph hit the x-axis? -1 and +3 and +7 and well, hold on, we're missing a root. There are 4 roots and I've only listed 3. 0. Right? What makes this 0? 7. What makes this 0? 3. What makes this 0? -1. What makes this 0? 0. Okay. Does this graph start from the top or the bottom? Well, it's an x to the fourth, so it's a w. So it's going to start at the bottom and end at the bottom. So something like this. Right? Okay. What about this? What is that going to look like? Positive 4, negative 1. How do you hit negative 4 twice or positive 4 twice? You bounce off that number. So if I had a parabola that has 2 roots, 2 roots, 2 roots, 2 roots, 2 roots, and those roots are getting closer together, and now those 2 roots have become 1 root. So it's sort of like a double root. So this is an x to the third. That's positive. Do I start at the bottom or start at the top? Start at the bottom. Where do I end? At the top. So at negative 1, I go straight through. And what happens at 4? It bounces off. That's what a double root does. Okay, but it doesn't look like they're going to make you do that. So, 3, 4. Oh, you guys didn't write it on the board. So we want to do 39 through... Is that what it was? Okay, so 39 through 63. Odd. Okay. So once you get to 57, 59, 61, and 63, you just solve them like we did before. Okay. All right. Get to work.